Today we're looking at the three types of data cables that will go into residential homes. You got Cat6, Cat6a, and fiber. Each of these serves sort of a different purpose, even though they are all different networking cables. These two being copper and this one being fiber or glass. So these three different cables is what you'll most commonly see in homes nowadays. We run all three of these. Cat6 for certain applications, Cat6a sometimes if you need it, and then fiber for a lot of your network backbone. So we want to go over the different types of construction, like how these things are being made, what kind of things you consider when you're ever going through the installing and terminating of these, the performance, like what fiber gets you that Cat cables don't, what kind of speed do you need through them, any time of maintenance things you need to consider, why you would use Cat6 versus Cat6a or vice versa, the price, so Cat6 cables, how much is this compared to this fiber cable, is it more efficient to do it this way, is it easier to do fiber, that sort of thing. And then also the cost, so whether one type of cable is more expensive than the other, or whether it's all sort of about the same. So we'll go over all that. So first is on the construction of cables. So these two cables, Cat6 and Cat6a, these are both copper cables. And so that means each of these little wires that's in here is a copper wire. And so here I've taken apart one of the pairs. So these are two copper wires. In each category cable, you'll have 4 pairs of copper wires that are twisted together. So I'll zoom in here so you can see it. You can see these different pairs are twisted together. That just helps the signal get processed through these. The different pairs sort of serve different purposes. So back in the day with phone lines, you would only need like 2 or 4 of these wires. But now with full data cables, you need all 4 pairs or 8 wires. You'll also notice that this cable has some other stuff going on with it. You have this central plastic spline that will sort of just help with the structure and the durability of the cable. It will also help separate the pairs, so it might be difficult to see, but the spline is sort of sectioned off so that each pair kind of fits into a certain point of the spline, so it'll help separate the pairs a little bit as well. Just provides a lot of good rigidity with the cable. You'll see in some cheaper cables they don't have this spline, so we always like to use these. They're just a little bit more sturdy, a little bit more resilient to pulls and bends and twists and things like that. There's also this sort of these strands here. That's really a tension relief strand. It sort of helps with, as you're pulling the cable, it sort of helps with tension around corners and things like that. You can also use it to pull and tear at this jacket. And so if you were to pull this, you can sort of help tear the jacket a little bit if you just need a little bit more off of the jacket. That's really just if you're editing this at all and you want to add a little bit more slack to your cable length. But most of the time we have a special tool to cut this out. Cat6a, you'll see it looks very similar to Cat6. Again, you got that spline, you got the 4 twisted pairs. This one I've already snipped off the little tension relief, but it might be tough to see here. Here, I'll show you the blue cables. The Cat6a cable has a bit of a tighter twist than the Cat6 cable. So this Cat6a, each of the pairs is twisted more tightly than the Cat6. That helps provide higher bandwidth, and so a lot of the reason people get Cat6a is because you can do higher bandwidth over longer distances, and one of the reasons for that is because these pairs are twisted so tightly together. Now, any technician will tell you that Cat6a is much more difficult to work with than Cat6, and part of that is because these are twisted so tightly together. It provides a ton of rigidity in this line, and so that's great for sturdiness and for keeping it safe as construction goes on, but it doesn't make it great for when you need to go around tight turns or need to sort of fit it in certain places or work it into a junction box when you're trying to terminate the cable. And so in general, Cat6 is going to be more expensive to work with and more difficult to pull. So Any technician will tell you that's just a little bit more challenging to work with, but it does give you higher bandwidth, so sometimes worth going into. Now, when we're looking at fiber, I'll sort of, if you flick this, you can sort of see the fibers a little bit. So these strands that you see here, these yellow strands, those are Kevlar strands, and so they help with strain relief similar to the category cables. This provides a ton of durability for these delicate fiber cores, and these strands are crucial to the strength of this cable. These fiber cores are very fragile, and so if this were just a cable made up of these cores, it would be very brittle, very easy to break. And so these Kevlar strands are super important. But if you can sort of see here, you have these really tiny colorful strands that are inside this cable. When I'm referring to the cable, I'm referring to this whole thing. And actually in this cable assembly, there are 4 strands. And so with fiber, you have send and receive. And so whereas for category cables, like this whole cable is one connection. So you can have one device or a switch or something hooked into this cable, and this provides one connection from the device to the switch. Whereas the fiber cables, you have to think about send and receive. And so you can do both in one strand, but usually you don't. It's only for a lot of ISPs will do that. But this has 4 strands, and so it has 2 send and 2 receive. And so you basically will get 2 connections out of this. And so in one cable, and this, you can tell obviously this yellow cable is much smaller. In one cable, you get 2 full connections instead of 1. And so big benefit for that is this is smaller, much lighter, much easier to work with, and provides more connections in one cable. Now this is a 4-strand micro distribution cable. I'm getting a little technical here, but you can have a ton of strands in one cable assembly. You can have like 128 strands in one cable assembly. And so theoretically you could have 64 different connections in one cable assembly. And because these are so small, the cable that you'd have is really not going to be much bigger than this category cable. So in one cable run, you can have 64 connections. So that's awesome for these like internet backbone connections. So building to building or house to house and site to site, that sort of thing. Over one cable, you can have tons of connections. So it's great for that. The other thing I want to talk about is interference. So a big benefit of fiber optic cabling is the lack of interference risk. So per the National Electric Code, you cannot have copper category cables within a certain distance from electrical wires. And so that's like Romex, or basically your home is 120 volt wiring. Part of the reason is for fire risk. The other part of the reason is that you will get electromagnetic interference through this cable from the electrical wiring. So if this cable is too close to an electrical cable, you'll get some interference. And so you'll have some issues with this. The connectivity is going to be unreliable. When certain things cut on, you might notice your signal drop or cut out totally. And that's because of electromagnetic interference, and because these are copper wires, and so they can conduct electricity, and they're also able to be induced by a magnetic field. And so they are affected by power wiring. Now, fiber cables are glass, and so they don't conduct electricity. In fact, there is nothing metallic in this entire cable. The Kevlar strands, the fiber cores, none of these are conductive. And so these are totally immune to electromagnetic interference just because it's not being conducted through this. And so there's really no restriction as to where these can go. There's obviously the general electrical code things that you can't put this in, but you don't run the risk of electromagnetic interference. So this is great for underground runs. It's great for runs near heavy machinery or anything like that. In residential homes, you don't run too much into interference unless you're running something massive, like if you need to run a wire like right past a generator. But a lot of times you're not going to run into too much EMI or electromagnetic interference with residential runs. But that's a big benefit for fiber cables. Okay, so performance is a big reason why you choose one of these cables over the others. In fact, it's really the primary difference between these. So when we start talking about the difference between Cat6, Cat6a, fiber, why would you use one over the other? A big question we get is like, what's the difference between Cat6, Cat6a? Why wouldn't you use Cat7 or Cat8? I see those online. Well, the first reason is Cat6 can do 10 gigabits per second over 164 feet. And so most residential local runs that go from a rack or from some sort of central hub to each port throughout the house or to certain devices, they're usually less than 164 feet. And so that allows you to have a 10 gigabit connection over Cat6, which is cheap to install. It's very standard. And so that's why we do this for most homes. Cat6a, everybody thinks it's better because it's newer, but really it just does what Cat6 can do over longer distances. So whereas Cat6 is limited to 164 feet to 10 gig, Cat6a can do 10 gig up to 330 feet. So just more than double the length limitation of Cat6. Now, Cat6 can do 1 gig over that 330 feet, and so it still is good for long runs that don't need a lot of bandwidth, so things like cameras and things like that. But Cat6 is good if you need high bandwidth and you need to have a long run. So we see a lot of times people will bury Cat6a if they're trying to connect two buildings. We've sort of gone away from doing that, but this is a common way to connect devices over long distances that need high bandwidth. When you start talking about Cat7 and Cat8, it gets to be in a little bit of the marketing and snake oil kind of area. So Cat7 is not an official standard from IEEE, which is the board that sort of certifies these CAT standards, category cable standards. Cat7, and you may have heard of Cat6e or Cat6 enhanced. That's also, but neither of those are official standards. And so while you may be able to buy one off Amazon, and you may be able to find it in some big box stores, they're not official standards, and they may have a few benefits here and there, but really Cat6, Cat6a are the official standards of around the 10 gigabit kind of speed. Cat8 is an official standard from IEEE. It's the official successor to Cat6a. And so the sequence would go Cat6, Cat6a, Cat8. But really Cat8 is limited to 25 gigs over 100 feet. And so if you're thinking, okay, this is 10 gigs over 330 feet, Cat6a, Cat8 is 25 gigs, but it's only over 100 feet. And we find that most runs get pretty close to 100 feet, and they're frequently longer than 100 feet, even in residential. And then Cat8 can also do 40 gig over 78 feet. And so that's great for short distances, very short runs. Patch cables, for example, connecting two switches together is great. But you really start to get to the point where, okay, the difference between a run of Cat6a versus a run of duplex single mode fiber is, there's a difference for sure, but you're like, okay, the difference between getting 10 gig versus getting, 3 petabits per second is pretty minimal compared to like Cat6a versus Cat8. You can get more bandwidth from that, but they're less available. The connectors are still expensive. You're still going over copper, and so Cat8 is starting to get to the point where for very niche applications where you have to have copper, or you don't have the infrastructure ready for fiber yet, you start to get where the jump between Cat6a and Cat8 is not worth it. You just jump all the way to fiber. Now, fiber, this is single mode fiber. There's two types of fiber. There's single mode and multi-mode. Single mode is really the most popular. It used to be that multi-mode was cheaper and it was better for local runs. That was sort of the recommendation for a while. But really nowadays, single mode has gotten much cheaper, and the price between the two have come really close together, both from terminations and from the bulk cable. And in fact, multi-mode actually has become more expensive because it's more difficult to manufacture that specific core that has multi-mode. I'm not going to get into the difference between single mode and multi-mode. That's sort of its own discussion, but single mode is probably the most popular nowadays, especially for longer runs and for shorter runs. It's the most popular. So the color of the jacket here is really important. This designates the contents of this cable assembly. So how many strands are in there dictates that it's single mode fiber. It designates the jacket type. So this is a riser jacket. And so this cable color actually is very important. But single mode in terms of speed limits is much different than these copper cables. So like I said, 10 gigabit is the limit on Cat6 cables. The practical limit of this cable is around 100 gigabits per second. And so that's 10 times what these copper cables can do. But really that's just a limit of most devices today, most transceivers and SFP cages that most devices have, like switches and routers. But really the limit of this technology is around like 3 petabits per second, which is sort of unfathomable for the type of speeds and technologies we're working with today. And so the theoretical speed of this technology is significantly higher than copper cabling. And so that's why you hear so many people talk about fiber being, the future of cabling infrastructure, the future of internet backbones, really because its bandwidth is so high and there's no electromagnetic interference with it. Now, that being said, you probably are not going to be pushing petabytes of data in the next 10 years in a residential setting. It's a great way to sort of future-proof a house for different connections. So even though you may not be using the entire bandwidth of the technology, it provides the future proofing that many devices are headed to. So a lot of switches and routers will already have SFP cages and connections in them so that you can connect fiber very easily to them. Most homes around big cities nowadays have fiber optic networks or internet services coming in. And so it's becoming much more popular. And so that's why we recommend it for tomorrow's technology versus using something like copper, which is sort of tried and true, and many devices today can connect to it. So one of the big questions when you're choosing between one of these three cables is what speed do you need and what speed do you want to plan for? So we always say copper for today, fiber for tomorrow. And so most of your devices today, from cameras to laptops to gaming systems and even a lot of network hardware, access points, switches, routers, they have the infrastructure built in for copper cabling. And so you have Ethernet cables that connect your router to your switch and your switch to different devices. And devices will have Ethernet ports on them, and that's where you connect to. And so if you ran fiber only throughout your whole house, you would quickly realize that none of your devices can accept a fiber optic connection. You would need these certain adapters, these transceivers in there to connect a Ethernet device to your fiber optic cabling. And then on the other side, connect your fiber optic cabling into your network system. So it's possible, it's not easy. A lot of devices have this sort of stuff built in, but most of them are sort of prosumer or enterprise level hardware. And so a lot of your common client devices will not be able to connect to this without expensive transceivers. So running copper cabling is cheap, it's easy, and it's standard. A lot of people are used to seeing this in walls. It looks like phone jacks if you still have those, and it's very intuitive to sort of take an Ethernet cable, plug it into the wall, plug it into your device, and that's all you need, versus having other adapters and stuff. And so we get a lot of people asking about future proofing. Like, I want to make sure my house is future proof for the next 10 years and for the next 50 years. And so That's why we say copper for today, fiber for tomorrow. And so a lot of times to one outlet, we will run like 1 or 2 Cat6 cables, and we'll run this cable, a 4-strand micro distribution single mode fiber. And so what that allows you is for today, you can plug in your devices as you're used to. So computers, access points, anything else that needs a hardwired connection, TVs, for example, those can very easily connect right into your network. And then let's say 10 years down the line, when copper is so outdated, like we talk about phone lines today being outdated, copper will eventually be outdated, and fiber, everyone will want to have that. And so you'll be glad you'll have those ports already ready to go when you want to connect your gaming system that has a fiber optic port right into your fiber optic line. It'll be a great low latency, high bandwidth connection without having to replace infrastructure in your home. That being said, a lot of times in homes we just run Cat6 and no fiber. The main reason is cost. The secondary reason though is a lot of times the amount of bandwidth that you get from a Cat6 cable will last a very long time. So to give you some speed recommendations, most coax internet providers, so that's like Xfinity, Spectrum, they have a lot of coax infrastructure. You will only be able to do up to 1 gigabit per second of internet speed. And so you can for sure get that over Cat6. You can actually get 10 gigabit over Cat6 over a certain distance. But even if you use copper and you have an Ethernet port, you think, okay, well, I have this Ethernet port on my TV and I want to have 40 gigs on my TV for some reason. You can't get 40 gigs out of the port on the back of your TV. Or for a computer, for example, if the Ethernet port on your computer cannot take that bandwidth, most are limited to 1 gig. Sometimes you get 2.5 or 10 gig Ethernet ports, 25 gigs even. You have to have a specific port on that device. And so more devices, instead of getting a 25 gig Ethernet port for copper, they will instead use an SFP cage to where you can use fiber. Most homes in the US are not using a full 1 gigabit connection. And so even though the internet service provider may sell you on the gigabit speed and it's going to change your life, most homes are not using anywhere close to that. It's really when you start getting to downloading large files, gaming tends to need to download a lot of large files. You have servers in your house. That's when people start to use a gigabit or more regularly. And so that's where Cat6 really excels. And so if you think about it today, people don't really need 1 gigabit. Most people have it, even just because the internet service provider has sold it and give discounts to give that. But then that will last for many years. Gigabit internet has been around for a very long time, and Cat6 can do 10 times that. And so it's a really great base level infrastructure that will last for, my guess is 10 to 20 years. Before you need to think about maybe we need to upgrade something, and really that is only your internet service backbone, not usually the local runs throughout your house. Now the biggest thing we want to talk about between these 3 different types of cables is when you would use one or the other. And so we already mentioned that we use copper for today, fiber for tomorrow, that sort of base level of infrastructure in a home, especially to crucial areas like you have a home office, or a gaming room or home theater, something like that. You want to have really good bandwidth to it, and you wanted to have some future proofing to that as well. But the main runs that we do in most homes I call them local runs. So that's from a rack or some sort of network hub to various devices throughout the house. So TVs, cameras, desks, laptops, places that you want to have good connections and you want to have it today. A lot of that will be Cat6 cable. It's easy to connect to. It's got really high bandwidth for what most users need today, and it will be supported for a very long time. So it's a great sort of base level. Let's just run Cat6 to each port around the house and have that just sort of readily available. For fiber, we generally run this they call them rack to rack. If you have multiple network hubs in your home or building to building, especially burial runs. So like we were saying, one of the big benefits of fiber is that it does not have electromagnetic interference. And so it's great for burial connections. So that is things like connecting a main house to an attached accessory dwelling unit, or maybe to a detached garage, or to like a pool house or something like that. Somewhere where you need a main backbone of network from your main area into sort of a secondary area. So we've seen that a lot. If somebody has like a guest house, we will run or bury a fiber line between the rack in the main house to the separate rack that's in the guest house. And so they'll provide a fantastic backbone for all the data that needs to travel between the secondary house and the main house. And so fiber is perfect for that. Again, you can run a single fiber cable and have up to like 64 different connections in one cable. And so you don't have to bury, 25 of these to be able to have 25 connections in the other house. You can have really just one or two connections through a single fiber optic cable, and have super high bandwidth, low latency connection from a secondary house to a primary house. This is also very applicable if you have a large house and you have your sort of rack or network hub maybe in the attic or somewhere that is maybe a mechanical room or something like that. And then you have these sort of like smaller racks or smaller hubs that have a lot of other devices. So this is very common for home theaters, where your mechanical room is on one part of the house, but then all of your home theater equipment is on a different part of the house. So you have your home theater with all the speakers and projector and screen and everything. And then right behind the wall or in a cubby somewhere, there's a small rack with amplifiers, receivers, and things like that. And so you want to have a very good connection to that rack, while also being able to have some redundant connections. In case any of those go bad, you still have a really good connection to your home theater, and you're not relying on Wi-Fi for your entire home theater to run. And so fiber is great for those rack-to-rack connections as sort of a great backbone for your home's network. The other reason we use copper over fiber is for PoE devices. So that's power over Ethernet. So that's when you want to have a device that is hardwired into the network and provides power over the same cable. The most common ones for these are cameras and ceiling-mounted access points, Wi-Fi access points. So a lot of cameras are PoE nowadays, and so that allows you to run one low voltage Cat6 wire from the rack or from your PoE switch to each of your cameras. And so just as we were saying before with fiber, it does not conduct electricity, which is great for electromagnetic interference, but it does not provide power. And so when you're running things for cameras and for access points, you want to run copper. And again, the only time you'd run Cat6a is if you needed really high bandwidth over a long distance. Cat6 gives you pretty much the same bandwidth over a shorter distance, which is great for most home runs. So the other time you'd run fiber in a house is for your internet service provider. So we always have a demarcation run, which connects the network hub or the rack to the outside of the house, so that AT&T, Xfinity, Spectrum, whoever you have, will be able to bring their service in from the street and meet at the side of the house where we have run all of our cables. We don't usually run fiber for the internet service provider. Instead, we'll run a conduit from a demarcation point or from the rack, depending on where things are located, out to the side of the house. And that allows the fiber provider to fish the cable straight through the conduit right into where the rack is. And so they don't have to worry about, did we terminate it the way they want it? Did we use the type of cable that they want? A lot of different internet service providers have different policies on this too. And so we tend to like to use conduit for those to connect or to allow the internet service provider to choose whatever way they want to install it or whatever wire they want to use. But many providers will allow you to run your own fiber as long as it's terminated the way they want. And that it can easily connect in their system. That way you don't have to run a giant conduit through the house to try to connect those. Finally, we want to talk cost. So that is one of the biggest reasons why someone would choose one cable over the other. In general, copper is cheaper than fiber. Now, fiber has gotten much cheaper nowadays with the popularity of it, the different manufacturing techniques. But copper's been around for a long time, and so it's just significantly cheaper. And so, to give you some numbers here, just per foot, Cat6 cable is about 25 cents per foot. Cat6a cable is about 45 cents per foot. And then single mode fiber, this specific one, which has 4 strands, so again, 2 connections for this one cable, is about 73 cents per foot. And so you might think that this Cat6 cable, okay, is 25 cents per foot. This is 73 cents per foot. And so that means fiber is 3 times as expensive as copper, which is simply not true. Really, the cost from these 2 cables is the termination and labor costs. So Cat6 cables and Cat6a have been around a long time. There's lots of tools and techniques to terminate those quickly. The connectors on the end, the keystones or RJ45 plugs, are very cheap compared to fiber. And so the other pieces that go into a full run of this is much more than the bulk cable itself. In general, when you're paying for a Cat6 run or drop in your house, you're paying for the labor of installing it, the extra connectors that are in it, the cable management, and the actual pulling of the cable. The bulk wire is one of the smallest portions of the end price. And so, to give you an example, so 25 cents per foot is Cat6, 45 cents per foot is Cat6a. You could say that this one's almost double the price. But really, for our prices, one drop of Cat6 is $195 for a 100-foot run. And then Cat6a is $225 for a 100-foot run. So you can tell they're actually much closer in price than they seem from their bulk cable prices. And really that's because of the labor. And so labor is going to be most of the cost for these. Again, Cat6 is a little bit thinner, a little bit easier to work with, a little bit more malleable. Cat6a is really stiff, really difficult to work with compared to Cat6. And they're both relatively easy to terminate. And so that makes the labor cost a lot cheaper. Now, moving to fiber in terms of cost, the biggest cost for fiber is terminations. Terminating fiber, it's getting better with better tools, better techniques, better constructions, but it still takes a while. For terminating a cable like this, again, there's 4 strands, so that's as if this cable was the same as 2 of these cables. It would take a while to terminate these. So as well, like a termination like this, to terminate this to a keystone maybe would take a few minutes, less than 5 minutes at most. Whereas this maybe takes you 10 minutes per strand. So it could be as much as 30 to 40 minutes to terminate this. Now, again, that's as you get better in training and things like that, that becomes faster and faster. But the safety when it comes to fiber makes it more difficult and more, you have to be more careful. You have to have a good, clean workspace, that whole thing. And you also have to be careful of dust when it comes to fiber. So because these are made of glass, you really have to worry about dust getting on your connectors, getting on the fiber itself. Any sort of scratches on it can really affect the quality of the signal. And so 90% of many fiber issues that we've seen are because of a dusty connector. And so dust control and clean workspace and all that becomes really important. Whereas for copper, you can almost just terminate it right into your hand and it's a perfect connection. Whereas this, you have to use a very special cleaver. Really, it's best to have it on a nice flat workspace. And so we even will set up a small little table to terminate fiber onto it. And so it just takes a while. It takes a little bit of setup, a little bit of cleanup. And so that's where a lot of the stuff you pay for with fiber is the terminations. The other part that's more expensive with fiber is the connectors. So the individual connectors. So again, 4 strands on this particular cable, 4 connectors on this side, 4 connectors on that side. And so you end up having a lot of connectors for one cable. and the connectors themselves are more expensive than copper RJ45 connectors. Again, they're getting cheaper, but in general, you need a lot more infrastructure to be able to terminate these. So another factor that comes in with fiber is when you actually install it in a home or in the final location. So again, let's use the most common scenario, which is rack to rack. So let's say you have a rack in the main house, you have a rack in a secondary building like a detached garage or a accessory dwelling unit, maybe a guest house, and you have a fiber line that connects the two homes. And so this cable will go directly into a rack, and you will need a safe way and a secure way to protect these cables these fibers, while also having a good solid connection there that you can easily plug and unplug regularly. And so a lot of times you'll have metal 1U rack modules that will sort of fit in, and those can get expensive, where you have to, you manage the cable into there, then you have this micro distribution block that separates all the different strands, allows you to connect them easily instead of having right now where they're all very, very close together. And so that allows it to be very protected. It allows you to manage each strand individually, be able to separate it out and terminate it one at a time. And so that level of infrastructure is much more expensive than copper, where you can have a simple patch panel that's $20 or something like that, that has the RJ45 or the Cat6 keystones can go directly into the patch panel, and the stability of the cable itself is all you need. Whereas fiber, you generally don't want a lot of weight being held on the fiber cable, and so you generally want to bring it into the rack, manage it around, terminate all the fibers, and distribute them from there. And so it just becomes a little bit more on the back end for these. And so while the bulk price of these two different types of cables are pretty similar in terms of per foot pricing, and a lot of people will say fiber prices are coming down, which they are. Really what you're paying for today is the terminations on these fiber cables. So a lot of times we will run fiber cable for a client, and the terminations is probably 70 to 80% of the cost of putting in a fiber line. So that whole infrastructure is really what you're paying for. The other part of this that we mentioned earlier is that a lot of devices today can connect directly to this cable and have a signal go from this cable to another device or to the rack or whatever you have, the network switch. With no other adapters, you really just need a very cheap patch cable or Ethernet cable to connect this into whatever you need. Now for fiber, if you wanted to use this today, you need a special type of connector if you want to use an older device or a current device, or you need a SFP enabled switch or device. So the connection is the end of a fiber cable. Usually we use LC connectors. There's lots of different types of connectors. We use LC connectors, and these a lot of times will go directly into a patch panel or something like that, or a fiber module. But from there, it needs to go into the device itself. And so whereas this connects into an Ethernet cable that's everybody's, or Ethernet RJ45 port or male end, that goes directly into a device, which a lot of people are familiar with. These cables end up with a much different connector and need the device itself to be ready for that. And so a lot of enterprise level switches and high-level home networking equipment will have SFP ports on them, and so basically that just allows you to have a fiber optic, two LC connectors go into this. The SFP device or transceiver is about the size of maybe half the size of a pen. It's about this big, and you connect the LC connectors into that, and then that whole device slides into this SFP cage that's in the switch or the router, whatever you're using, and so that utilizes a fiber connection, and it connects it in with the circuitry of the switch, whatever you're using, and those SFP transceivers those can get expensive depending on what bandwidth you want. So typical 1 gigabit SFP transceivers are pretty affordable. They're $10 to $20 usually. And then once you get up higher and higher bandwidth, they get more expensive. So a 10 gigabit one is even more expensive. And then once you get into like 100 gigabit or more, you end up starting to spend over $100 per connection on these fiber cables. And so if you're like, I'll run fiber today and I'll have 100 gigabit to every single device in my house, it really gets expensive quickly because you need 100 gigabit SFP transceivers at each device to be able to connect this fiber into that. Now, some devices will take direct connections from LC connectors, but most will not. So those SFP transceivers can really get expensive if you're doing a ton of these at very, very high bandwidths. So thanks for watching, everybody. That's the difference between Cat6, Cat6a, and fiber, why we choose them to run certain ones at certain times. If you have any questions, I know it can get confusing, put them in the comments and we'll respond to them, or send us a DM and we'll get back to you as soon as we can. But thanks for watching, and we'll see you in the next one.